Okay, trig proofs. I have some strategies for us here with algebra. So a first strategy with trig proofs is substitutions. So we all have a bunch of substitutions here and a bunch of substitutions here, like that kind of stuff. I also want you to write on this side, let's write this down. Cosecant of an angle could also be substituted with 1 over, you tell me, cosecant is 1 over, it's the flip of which one? Sine. And secant could be replaced with 1 over cos. Now, tan is a y over an x, which could be substituted with sine theta over cos theta. Right? The sine trig value is the y, and the cos trig value is the x. Therefore, cotangent could also be replaced with cos theta over sine theta. Okay, so those
I haven't downloaded here.
are some replacements we could do and on the front side. So we just did some of these examples. So tangent could be sine x over cos x. You notice how I switched my variable? Before I had a theta, now I have an x. We just said this one, secant, could be replaced with 1 over cos x. And that was from the back side. So cos squared x could be replaced with, to the front side, we wrote these out, right? So we wrote this out yesterday. So cos squared could be replaced with 1 minus sine squared x. Okay, so you can find replacements and substitutions, a bunch of things. So there's endless ones like that. Okay, some other strategies you're going to need. You're going to have to understand how to add and subtract fractions. So when you add and subtract fractions, you're going to need a, what's the big idea with common denominator, right? So 1 over sine x plus sine x, really, right now, that's over 1. So what do I need to have as a bottom? If this is sine x, I want to change this bottom to also be sine x, so I can put them together. So to change this to sine x, which I did, what did I do here? I times that by sine x, which means this would become sine squared on the top. Do you see that? Because if I times this by sine x, I would have to also times this by sine x. Okay, you can do cancellations. So if I ever have fractions like this, sine x divided by sine squared x, what could I divide out? I could say divide by sine x, and that would be gone, making, what happens when you cancel something in math? Is it 0 or 1? 1. And then if I take out a sine x out of a sine squared x, I would just get rid of the squared, right? So I canceled, and it made 1 over sine x, which is cosecant. Okay, here's another strategy. It's called split the fraction. So 1 plus sine x all over sine x, I could separate. So this would be 1 over sine x plus sine x over sine x. So you see how I split them apart? 1 over sine x plus sine x over sine x. Then I did my substitution. What is 1 over sine x? Cosecant. What's sine x over sine x? 1. Okay, look how much algebra is here. So we've done common denominator, thinking about algebra that way. Canceling, we've done all this in grade 11. We've reduced fractions. We are now going to talk about factoring. So probably the common types would be difference of squares. Look for that. Another common type would probably be GCF. You might see simple trinomials. I don't think we have a lot of complex trinomials that we see in this. Okay, do you know how to be like, boom, yeah, that's a difference of squares, recognizing it. That's what you got to get good at, just recognizing where you see. So 1 subtract cos squared. What do you recognize as that factoring style? Do you see a style? What would this be called? A difference of squares? You see it? So then 2 brackets. 1 times 1 makes 1. Cos x times cos x makes cos squared x. And what do you always know about difference of squares? There's always a plus and a minus, right? Then on the bottom, do you see this term and this term? Both have something in common that I could divide out. So that's a GCF. So I took a sine x out. So this would be what I'm left with. Now, 1 plus cos x and 1 plus cos x would be able to cancel. So that's what I'm left with after my cancel. Then, look at this. I'm going to split this apart. 1 over sine x, subtract cos x over sine x. So that was my split. And then I go into my substitutions. So 1 over sine, the flip of sine is cosecant. Cos over sine is cotangent. See, there was a lot of stuff going on in that one. Okay, and another strategy with algebra is the other one we've learned in grade 11, conjugates. Do you remember conjugates, that word? So when I see this, I multiply by the conjugate. So this is a conjugate. If this is 1 plus sine x, then the conjugate is 1 minus sine x. But if I do that to the top, I need to also do that to the bottom, right? Just keeping it the same, doing something to the top and the bottom. So this creates a difference of squares, right? If you FOIL it out, it's really a FLA. Do you remember conjugates? Right? It's like a difference of squares. Those in the middle cancel. And then I keep this. Okay, and then we would be going further, but I'm not going to get there yet. Okay, so let's start with baby steps. Okay, a proof. Starting point. Which side should I start with? Which one looks more complicated? This side or this side? Which one looks more complex? That one looks way more complex than that, right? There's nothing to do there. Okay, so I'm going to start on this side. Let's talk about substitutions. Can we substitute anything in for a replacement? Tan is the only thing I can substitute for.
Why?
Because there's nothing cos can be replaced with at all. Cos and tan are the final endgame. You can never replace them with anything. So what does tan of an angle could get replaced with? Remember we did this on the sheet? You could replace it with a sine theta over cos theta. Okay, and then I'm going to times by a cos theta. If you would like, you can write it over 1. You don't need to, but. And then what could happen? That would cancel, right? And we would end up with sine theta. And look at that. It matches the other side. So I'm going to write some kind of, no, what was it? Latin QED. I can't remember what it stands for, but it just means I did it. So in Latin. I don't remember what it stands for. Okay. When you do a proofs, you never do equal signs. You never write equal signs. You just work down until you get to the result. Okay. If you were to instinctively pick a side to start with, which side would you start with? Which one looks probably more complicated? This fraction looks more complicated, right? Okay. I'm thinking just substitutions right now. Let's start with that. What can you replace secant theta with? It's the flip of cos. So I replace secant with 1 over cos theta. Divide by. What can I replace cosecant with? 1 over sine theta. Okay, what happens in math when you have a fraction divided by a fraction? What do you want to do with that? Multiply and flip. So multiply and flip makes us get sine theta over cos theta. What can we replace this fraction with? We can replace that with a tan theta. And guess what? We have a match. QED. I gotta go.
Is it QED?
Yeah. I need to look that up what it meant again. I just say I did it. Okay.
With that, do we lose marks?
No.
Okay.
Or sometimes you might see me write left-hand side equals right-hand side.
Oh, okay.
I might write that sometimes to show you at the end like I did it. Okay. Okay, what do you want to start with? The next one. Which one looks more complicated to you?
Oh.
I feel like this side, right? Because this is already in coses and sines, so I can't really go anywhere with, you know what I mean? Once you're in coses and sines, you have nowhere to go. Okay, cotangent. Give me a replacement from your formula sheet there. You're on the back side. Cotangent. Please remember that this time I have an x variable. Last time you saw me doing a theta. Now I'm going to be using an x as my variable. So cotangent. So we're replacing with cos x over sin x. What do you want to replace tangent with? Sin x over cosine x. Okay, algebra time. I'm going to add 2 fractions. What do I need to add 2 fractions? I need some kind of common denominator. Okay, what do I need in my denominator to make sure I can fit everything in there? I need a sine x and a cosine x. That's your common denominator. You need both. Just like if one fraction had a 4 and one had a 7, you would need a 28, right? Same idea? Okay, look at this first fraction. What did you do to the bottom? This bottom did what? Looks like you had to multiply it by a cos. So therefore, I better multiply the top by a cos,
Yep.
which causes us to get cos squared x. Do you notice how somebody who would write me this would get this wrong? Cos of x squared is wrong.
Me too.
Cos of squared of x is the right way to write it. Okay. Second fraction, look at the bottom, look at the bottom. What did you have to physically do to the bottom? Multiply it by a sign, so I better also multiply the top by a sign, which makes sine squared of x. Ooh, the top. Cos squared plus sine squared might be something. Do you see what it is? If you add cos squared plus sine squared, you get a 1. So I can put a 1 as a replacement, a substitution, at the very, very, very top. And we're done. We matched it. Okay?
Just fold it on the table.
Okay, first pick which side you would start with. Which one looks way more complicated? I would say that one looks more complicated. Okay, now when I look at the end game here, there's only really sine stuff. This is a sine flip. So at the end here, do you notice how we have nothing to do with coses in the end? There's no cos ever in this part. So is there something I can substitute for this? Can you look as a substitution? It would be in the top left corner of your formula sheet. Cos squared, I can replace it with
Yeah, I have to just. Damn it, my robot.
Okay, I'm going to tell you a big common mistake. Please don't ever do this. I have people who try to cancel the sine squareds. You cannot do that. You can only cancel something when it's connected with multiplication. Do you remember me kind of explaining like this? Is canceling the 5 allowed? No. Can't cancel the 5. If I did this, could I cancel the 5s? Can't cancel adders. You can cancel multipliers. So you can't cancel that. Don't try it. Everybody always tries it because they think it's going to make them get there. It's not. Okay, I need you to factor the top and factor the bottom. Can you recognize some stuff? You're going to factor both of them actually. Factoring the top gets you a difference of squares. Go ahead. Factor a difference of squares on the top. Two brackets. What times what in the front? Plus minus. Okay, factor the bottom, what's the style? GCF. So out of this term and this term, I could take a sine x out, leaving me with sine x times 1, sine x times that was my factors, good. Now I can cancel that because it's this brackets times this brackets, right? Okay, you know what? I think I'm going to jump to the other side now. Is that okay? I can split the fraction here if you want it as well, but I'm going to go to the other side. Okay, 1 plus, replace. What's the replacement of cosecant? 1 over sine. Okay, to get this and this together, I would need the bottom to be the same. So I would change both of the bottoms to be sine x. So if I was to change this bottom to a sine x, I would have to multiply by sine x. To get this bottom to change to sine x, I would multiply by sine x. So that's the top changes. And then this one, leave. And look at that. We got to the same. QED, we did it. Okay. Now this one gets a little bit, I kind of have been progressing here. I started really easy. This is like a medium one. Okay. Which side would you say we want to start with? I'm going to actually start with this side. And here's the reasoning, is because I'm going to do a conjugate. Okay, so I recognize this to be, hey, I should do a conjugate of something.
How did you recognize that?
1 plus sine of x, or
Conjugate base.
yeah, whenever you have like 1 minus cos x, or 1 plus cos x, or 1 minus sine x, or 1 plus sine x.
Oh, it kind of makes sense, conjugate base and conjugate acid. It's like the opposite of them. Neutralizing them from the weakest and strongest.
Yeah, so
Awesome.
those are the things you would most likely see for that strategy that you want to tackle. Okay? So when you see something like that on a fraction, Okay, so what is the conjugate that I'm going to put onto this? 1 plus sine x, 1 plus sine x. Okay, leave the top as is. And you're going to FOIL the bottom, but you can cheat and just FLU it because of what conjugates do, just like the difference of squares, right? They always cancel in the middle. So what is the FLU? Because the foiling is just a FLU. Okay. You ready for the next step? Everyone's good with that one? We FLU'd this. I need you to think about this line and make a replacement. What can I replace 1 subtract sine squared with? Did you find something? It's hint on the top left. It's just a cos squared x. Now, what would you do next?
How do we get to that?
What do you want to do next with some stuff?
How did that become? Oh, okay.
Anything? See anything? Cancellations of anything? Anything cancel?
Yep.
What?
The little coast and the little other coast.
Cos. I can go cos out. So if I take a cos out, this would be gone. And if I take a cos out of a cos squared, are you okay if I just scratch off the 2? Okay, you know what I'm going to do? I'm going to get to the other side a little bit here.
So you're deciding to do that because you're like looking at it like, I don't know how it's going to go.
Yeah, or I could split the fraction as well, just like the last time. I could go like this plus this, separated fractions, which would get me to there in one more step, if you wanted to as well. Okay, I look at my, apparently I did this in tax season. Tan, not tax. Tan x, I don't know why. That's just like on my wedding invitations when I wrote RRSPs.
Did tax us last year.
Instead of, what, RSVP? Yeah, no one noticed.
Sure.
Tan x is replaced with, what over what? Sine x over cos x. Secant can get replaced with 1 over cos x. Then, to put them together, I need them over the same bottom, but they already are the same bottom. So sine x plus 1 over cos x. And they look the same. We did it.
Yeah, you say that now.